Hello friends, I am Gaurav Kapoor, Assistant Professor in the Department of Electrical Engineering, Modi Institute of Technology, Kota. Today we will discuss few topics of the power system protection, and the topics are fault analysis and what are the main objectives of fault analysis. The second topic is relay, third one is circuit breaker, and fourth one is the classification of circuit breaker. Next one is distance protection, and then generator protection. Fault analysis. What do you mean by fault analysis? A fault is an abnormal condition in a power system. Basically, there are two types of faults, symmetrical faults, and the second one is unsymmetrical faults. The first one, symmetrical fault, are also known as balanced fault. A fault which involves short circuiting of all three phases of a circuit or a system involving ground or without ground are known as symmetrical or balanced faults. Example, three phase to ground fault or three phase fault, ABCG or ABC fault. Basically, it is a very rarely occurring fault, but it is the most severe one among all the types of faults. The second category of fault is unsymmetrical, which are also known as unbalanced faults. These types of fault involve short circuiting of two phases involving ground or without ground. These are also known as single line to ground fault or double line to ground fault or line to line faults. These types of faults causes the flow of unbalanced currents in a system. Like the examples of unsymmetrical or unbalanced faults are AG, BG, CG, and double line to ground faults ABG, BCG, ACG, AB, BC, and AC faults. Now, what are the main objectives of fault analysis? The first objective of fault analysis is to find the maximum and minimum values of symmetrical fault currents. Thereafter, to find the current distribution and current setting of all the relays which are placed in a power system. The next one and the main objective is to find the unsymmetrical fault currents. Relays. what what do you mean by relay? A relay is an automatic switch or an automatic device which detects an abnormal or fault situation in an electrical system and gives a command to a circuit breaker to isolate the faulty element of a system. Basically, there are many types of relays, but here I have listed the 7 types of relays. The first one is electromagnetic type relay, which operates on the principle of electromagnetism. The second relay is static relay, and these relays are also known as solid state relays, which employ semiconductor devices like diode, thyristor, and logic gates or ICs. The third one of relay is overcurrent relay, which operates on the principle of overcurrent. When the current exceeds the preset threshold value, the relay actuates. The next one is over voltage relay. It is a kind of relay when a voltage exceeds the preset threshold value of voltage, the relay over voltage relay will actuate. The next one is under voltage relay. Uh, After that, directional relays. Directional relays are the types of relays which operates on and depends upon the direction of voltage or current signal. The next one is inverse time relays. Now, circuit breaker. What do you mean by circuit breaker? It is an automatic switch which can interrupt a fault current. It is also known as an AC isolator, which is used to isolate the faulty element of a power system upon the occurrence of fault. The part of a circuit breaker connected in one phase is called as a pole. So, a circuit breaker used for the protection of a three-phase system is called a triple pole circuit breaker. And the circuit breaker which is used for the protection of a single phase system is known as a single pole circuit breaker. There are basically two contacts of a circuit breaker. The first one is a fixed contact and the another one is moving contact. The arc produced upon the separation of the contacts during the occurrence of fault can be extinguished or can be suppressed by using oil or air as medium. Whenever we used oil, the circuit breaker are known as oil circuit breaker, and whenever we use air as an extinguishing medium, these type of circuit breaker are known as air blast or air brake circuit breakers. Next, classification of circuit breaker. Basically, the classification of circuit breaker are mainly divided into two parts. The first one is based on voltage and another one is based on arc quenching medium. So firstly, we will discuss about the classification of circuit breaker based on voltage. Firstly, based on voltage, there are five types of circuit breakers classified according to the voltage level. Firstly, the low voltage circuit breaker. These types of circuit breaker are installed whenever the voltage is less than 1 kilovolts. The next one is medium voltage circuit breaker. These types of voltage, these type of circuit breaker are installed where the voltage is between 1 kV to 52 kV. The next one is high voltage circuit breaker. These type of circuit breaker are installed where the voltage is between 66 kilovolt to 220 kilovolt. The next one is extra high voltage EHV circuit breakers. These types of circuit breakers are connected where the voltage is between 300 kV to 765 kV. And the next one is UHV circuit breaker. These are also known as ultra high voltage circuit breaker, which are installed where the voltage exceeds greater than 765 kV. The next one is based on arc quenching medium. There are basically five types of circuit breaker uh, classified according to the arc quenching medium. The first one is air brake circuit breaker, which utilizes or which employs air as a arc quenching medium. The second one is oil circuit breaker, which employs oil for the quenching of arc whenever the contact separates. The next one is air blast circuit breaker, which also employs a blast of air for the quenching of arc in a circuit breaker upon the occurrence of fault. The next one is sulfur hexafluoride circuit breaker, which is also known as SF6 circuit breaker. The fifth one is vacuum circuit breaker. So there are five types of circuit breaker which can be used for the protection of a power system. The next topic we will study about the distance protection. What do you mean by distance protection? It is widely used for the protection of transmission line, and the transmission line which the distance protection come under are known as high voltage or extra high voltage transmission line. A number of distance relays are employed in this type of scheme or in distance protection, which measure the impedance or reactance of a relay location. The distance relays are used for the protection of 220 kilovolt transmission line, 132 kilovolt transmission line, 66 kilovolt transmission line, and 33 kilovolt of transmission lines. Basically, a single scheme has the capability to provide both primary and backup protection. There are many types of distance protection schemes: impedance relay, reactance relay, Moho relay, angle impedance relay, quadrilateral relay, and elliptical relay all come under the category of distance protection, and all these types of relays are used for the protection of high voltage and extra high voltage transmission lines. The next topic is generator protection. A generator, we all know a generator or an alternator is a very costliest equipment of a power system, and the protection scheme provided for the generator protection are depend on stator protection, rotor protection, and there are many miscellaneous types of protection for the overall protection of generator. So firstly we will discuss about the three types of stator protection schemes. Firstly, percentage differential protection. We all know the differential protection scheme. Differential protection scheme where the CTs or a current transformer are installed at both side of a protective equipment which is used for the protection. So this type of scheme is known as differential protection. The next one for the protection of stator is protection against stator interturn fault, and the third one is stator overheating protection. So in stator overheating protection, a cooling medium with a relay both are installed for the protection of stator against overheating. The next topic is rotor protection. For the protection of rotor, basically there are three types of schemes. Firstly, field ground protection. The next one is loss of excitation protection, and the third one is protection against overheating due to unbalanced three-phase stator currents. The third category is miscellaneous protection scheme, which are also known as over voltage protection of generator, over speed protection of generator, and protection against motoring and vibrations. So these are the various topics of power system protection or protection of power system of 6th semester electrical engineering branch.